Okay,
This conference will now be recorded.
Okay, so Insight is part of a tool that has been developed by the Intelligent Infrastructure Program. It's a tool that has multiple facets around looking at predict and prevent for the rail infrastructure. So it covers signaling, track, it covers civils, it covers E&P, but it also has other elements of the tool of looking to make a lot of more information that we currently have on paper, making that digital so that it can be fed into the tool. It also has a lot of functionality around being able to help with planning. So as part of a whole asset management system, we can look at, we've got a defect, we've got, we want to fix it, how do I create a work order, how do I get that in the plan, how do I measure the effectiveness of that work order once it's been executed, all these sort of things. This is what we're trying to build into the tool. And currently the tool is just about to be launched out on a wider scale than the pilots we've been running for the last year. And the tool, as I say, is a suite of various different products that will build so that eventually it's a one-stop shop for an engineer. Currently, we have lots of disparate systems in Network Rail with information in different places that really all needs to be brought together to allow an engineer to make a more informed decision when thinking about doing an intervention, be it even just as small as, you know, a basic manual intervention, right through up to a machine intervention, right through to possibly a renewals project. So what we're going to talk about first today is there's two elements to the bit we're going to talk about today. The first is the track geometry and cyclic top element of the tool that we've built, and then we'll look at some of the rail management side of the tool as well. So what is Insight? So Insight is a web-based tool, and it's replaced a number of portal-based tools, access databases and things like that we had in Network Rail. And as I say, what we're trying to do is pull it all into a place where it's accessible to everybody. So by making it a web-based tool, it's a lot easier for everybody to access. Their Network Rail login gives them access to the tool. They can access it on a laptop, desktop. They can access it on an iPad. It will even work trackside in a place of safety, obviously, because we know it works on even down to a 3G signal. It doesn't need to be connected to the Network Rail web. That in itself is a great selling point for the tool, and you'll see in a video later of how that was quite a key piece of functionality that a team was managed to be able to use to cure an issue they'd had for a long time. What the tool does, it takes the data predominantly at the moment from our measurement train fleet, although we are looking to expand that data capture to other pieces of equipment and also to service trains, so starting to bring in data from operators such as Hitachi, Bombardier and Siemens, people like that who've got or equipment measuring the track as the trains run along. What we're trying to do is then take that data in and then running it through a series of alignment algorithms. We start to align the data so that as we've aligned the data, we know we're always looking in the same place on the track every time. It's an issue currently for our existing measurement fleet that sometimes it's not always recording in the same place, so we don't have that full history of one point in the track. And what we're trying to do with our tool is through the enhanced capabilities we built within the tool, we can overcome those issues, so we know we're always looking in the same place. From there, we then use regression algorithms to look at how is that particular part of the track or whatever the system is we're looking at. So it could be an OLE, heights and staggers, etc. How is that performed over time? And then projecting that forward, what is going to happen in that particular part of the infrastructure going forwards to understand at what point is it going to pass the threshold. And it's a threshold then obviously of what we need to, at what point do we need to do an intervention. It's not a tool to make decisions for engineers. It's there to help them in their the support making process. One of the first comments I had thrown at me was, no algorithm is going to tell me how to do my job. That's not the point of the tool. The point of the tool is there to use algorithms and things like that to help pull all data into one place, make it more intelligent, so it's not just more data being thrown at engineers. There's a level of intelligence behind it too. What we're going to show you today is nowhere near the finished product. We've got another set of releases of bits of functionality coming soon. We're incorporating things like our plain line pattern recognition data and imagery into the tool. We're then looking at how do we incorporate where a route has an RBM regime, risk-based maintenance regime. How do we incorporate that in the tool so the tool reacts to that regime? How do we present the engineers with even more intelligence, especially around intervention effectiveness? You did this in the past. How long did it last? What was the benefit? All these sorts of things. So there's a lot more enhancements to the tool to go on through the rest of CP6 and into CP7. So what are we trying to do? So what we're trying to do is we're trying to move up a P2F curve, so away from the F end of the curve, which is where, as a business, we tended to be predominant in the past, where sadly at that end of the curve we get less and less time to actually go and fix something. We're not always able to do the optimal fix because of time pressures, access pressures and things like that. So what we're trying to do is, through the tool and being able to predict further out, we're able to move further up that curve to what we call alert limit. So that's the first time that maintenance activity needs to be thought about, really, even ahead of that by up to 90 days. So we're trying to predict up to 90 days of when something's going to pass alert limit. And then what we do is then we forecast over the next 365 days to show what's going to happen with that particular risk site that the tool has created. By doing this, hopefully we're buying the engineers more time to go and plan to do that optimal fix. And through using other functionality in the tool, like being able to group defects together, we can look to see how we're not just solving one thing, we're potentially looking at root causes of many different issues in the track. So what the engineers get is the aligned traces. So this is a set of traces, one on top of each other, anything back to the last 12 traces. And then using that, and where you've got the blue shaded area in the top left chart, we turn that on its side, so we start looking through time rather than through distance. And what we're looking at there is how that particular point in the track is degrading and projecting that forward as to when it's going to pass the threshold. The other interesting and exciting part of the tool is being able to visualize cyclic top faults and visualize how a cyclic top candidate is building over time as well. So not looking at where we've got confirmed sites already, but where we've got risk sites, where it's building, and at what speed is that cyclic issue building, and what degree is it going to go through to. So we can even look at areas where they're not even a category D, the lowest category of cyclic top fault at the moment. Engineers probably not even aware it's there. And we stop the I didn't see that cyclic top fault coming scenario, because we're predicting them going forwards and starting to look at the root causes again. So for an engineer, what does this mean? So through the tool and through risk calculation scores in the tool as well, which gives an idea of which particular defects are heading towards service affecting failures the soonest. It helps them to, where there are, let's say, limited resources, limited access opportunities, to prioritize their track geometry faults. Hopefully by the accuracy of our predictions, which we are working constantly to improve, around about 72% accurate at the moment, that we get the right measurement train window of when that defect will occur. We're trying to improve that even more through use of machine learning, more data. We give the engineers the confidence that if they don't do anything, that defect is going to happen. Therefore, we need to plan that work in to do it. So before, by putting all the data into one place, we can look at to better analyze the root cause, and especially if we've got a cyclic top, what is the trigger for that cyclic top? And then by doing the ultimate fix and optimal fix, then hopefully we get fewer repeat failures. Better access planning, by having that more longer time period to plan, hopefully we can get into the right access opportunities. But the tool will also support a late notice request, because if it can be proven through degradation and things like that, that fault is deteriorating quickly, it does give an engineer a chance to apply for that late notice change. And then by, as I say, grouping interventions, so we can look at different levels of defects. So we can group by defect type, we can group by location, track ID, all sorts of different things. It gives a more rounded picture to an engineer. Quickly go through this. This is the rollout profile of what we're looking at the moment. So track geometry and cyclic top, we've just finally got national union consultation to move forward, agreement on that and on PLPR. So we're looking to roll that out once we've got local, we've informed the local area councils, and this will move forward very, very quickly. So we should start rolling this out from around May onwards. PLPR, as I say, follows very quickly on the back of track geometry, and then later on this year, then RBM will come along as well. There are also lots of other things going in the background, so our team is heavily involved in the R&D of building the business case and building the support tools and the functionality for other parts of the tool. So what I'm going to do now is hand over to Rob York, who's going to show you a demonstration of the live tool and information in the live tool. And then we'll come back and see, get some commentary on what people think who are actually using the tool. So over to you, Rob.
Thank you, Paul. Right, I just share my screen. Hopefully everyone can see that now. Okay. So hello everyone. I'm Rob York. I'm the lead business analyst on the Insight project. Within the II, the Intelligent Infrastructure Program. What I wanted to do today was to show the Insight tool in live operation, which is always a bit nerve-wracking in these circumstances, and show some practical examples of how it might enable track maintenance teams to work a bit differently. What I'm showing here is our test environment, so that I can't do any damage. And the data within here is live, but it's not a comprehensive set of data. So as a user, I'd log in, and this is my landing page. And what Insight does is it's providing me a view of interest for me. So it's filtered it down to my area of interest, and it's providing me the information that I need to know for the role that I'm performing. So as Paul explained, we're trying to move up the P2F curve. So we're trying to identify and manage defects earlier in its degradation life. So I'm going to click on my alert level and pre-alert faults. So what this is showing me here is for my section, as a section manager, my section manager area, I've got a list of faults which are either at a alert limit, or they are predicted to be alert limit within 90 days. You can see, so the top one here, we've got a top fault, 35 meter top on the left rail, and we can see the location of that defect. We can see that it's a pre-alert, so it hasn't even got to that sort of fault level yet, where it would normally be identified. But according to the predictions in Insight, that's likely to become IL by July or in July. And that hence why, despite being a pre-alert, we've actually got quite a high risk score associated with this defect. This is based on its rate of degradation. We can also see for this that when we would predict that the intervention is due to be carried out for this particular defect, based on the standards, and we also have the status here. So the status is important because it's telling us in this instance that we haven't looked at this yet. It's the first time, potentially it's the first time it's recorded, or first time we've come to look at it. And but we could also have a status that tells us that it's we've got work planned against it. So we should be okay. We should already have plans in place to remediate the fault. So the status is helping us to manage it, and I'll talk a bit more about that later. If I now come down here, we can see the run-on-run trace, as we call it. And on here you can see the there's a condition over time. And the key to Insight and what's enabled a lot of things we do in Insight is an alignment algorithm that we've got. So this is taking the traces from the measurement trains and shifting them left and right and squishing them and stretching them so that you can get that alignment between the based on the signals of the actual trace itself. So this means that the bits that are interested in degradation is relevant to a single point on the track. We can see that this example is actually quite a nice example of its degradation, and we can see that the fault is actually degrading through to the alert level quite quickly within the last runs. And actually, if we were to switch on the traces one by one, you can see that degradation, and you can see it growing. And actually, if I scroll down to the rate of degradation chart, you can see that plotted, as Paul was explaining earlier. You can see that plotted over time. So we also have on this chart information around the interventions. So this is quite an interesting example. We can see that there was a TAMP carried out in October. This had an improvement, so it's obviously improved condition, but the condition's gone off quite quickly since. We can then see that we had another intervention carried out in January, which appears to have had very little, if any, effect on the condition. And then actually we can see that at the beginning of this month, there was a TSR or an ESR applied, and I did a little bit more digging, and it would appear that that was as a result of a rough ride report. So we can presume that, or I can see from that we've got a top fault that's not even at alert level yet, and another one at alert level, and that's actually triggered a rough ride report that's resulted in a speed restriction. So it's quite an interesting example, I think, that we see there. And again, coming back up to this run and run chart, we've got these things we call the defect markers, and it's showing where we have other faults and defects on here. What's quite good about this is because we've now pulled in the PLPR information, I can actually see that there's a potential voiding or top fault at that same location. And if I was to zoom in on here, you can actually see that there's some early signs of voiding. I think if we look at this and potentially with some sort of dampness on the sleepers there, that might be a sign of a wet bed. So we're kind of, by pulling this information together, we've learned, I think we can see from here that what the potential cause is of that top fault, which has resulted in an ESR. And we can use that information to go out and say, well, I'm going to fix, I would go out and perhaps fix these 4 geometry faults and the PLPR defect. So that's sort of consolidating the work, as Paul talked about earlier. But also we use this information to help us understand what might be the cause of that particular fault. The other thing that I want to show on here is that we have a cyclic top fault. So the cyclic top fault is actually just up or just down the road from that the top faults that I just showed. And we can see that it's again, it's a pre-alert cyclic top fault, so it isn't yet reportable. And you can see, and the reason why it's not reportable is because we've only got 2 peaks on this 18-meter wavelength. We've only got 2 peaks that are over the 5mm threshold, and we need 3 peaks for it to be a cyclic top event. But we can see the 3rd peak is actually very close to getting to that threshold, so hence why it's been reported by Insight as a pre-alert. And if I go down to a degradation chart for cyclic top, we can see that actually it's anticipated that pretty much over the last week or so, we would have expected that peak to have popped up above the threshold, and that's given us that step in the degradation chart. But not only for the left rail, but also for the right rail. So if I switch to the right rail, you can actually see the same, a very similar pattern of the degradation there. There we go. See, it's a very similar cyclotop pattern there. But and so what's probably more concerning, I guess, from a maintenance team perspective here is that whilst we've got the left and the right rail degrading at a certain rate, and we've got prediction for that to become Cat D in was about April time, and then it's predicted to get to Cat B at some point in June. But when you combine the two, and they're both cyclotop events, that will overtake those, and that's predicted to become a Cat I in some point in June, which is where we start to have impact on the on performance of the network and have a service impact. If I come back up, I'll just explain the rest of the charts on this page while I'm here. So we can, as well as the peak amplitude chart, which is the first chart we started here, we've got an cumulative value chart. So this is showing the cumulative energy that's built up for each of the peaks. In this instance, those two, and you can see that we're getting sort of very similar energy build up on the left and the right rails there. We can see something we call a multi-wavelength view, which is saying that as well as the 18-meter wavelength on the left and the right, we're starting to get some 13-meter wavelength events occurring. So we've got a peak there, single peak. And then we've got what we call the rolling SD chart. So this is taking top track quality as a rolling eighth, and then and you can see from here then that we've got poor track quality at the point where, oh sorry, I don't say poor, we've got track quality condition here that is at the point of the cyclotop, but also precedes it, which happens to be where that top fault I showed you earlier was. So we can see that sort of gives some indication of the area we might need to treat. So that's a cyclic top page. What I also want to, so what I wanted to sort of also talk about is the sort of side effect or the symptom of moving up the P2F curve is that we're going to have defects in the system for a lot longer because we have longer to fix it. So that gives us all the benefit of being able to plan in advance and get all the things, all the benefits that Paul talked about. But the downside of that is that you're going to, if you've got a measurement train running, say, every 4 weeks, you're going to be told about that defect every 4 weeks for, let's say, 6 months. So that gives you an overhead to try and rationalize all that information and recognize that it's the same defect. So what Insight does is it actually will do that for you, and it will, each time the train runs, it will recognize it's the same defect, and it will essentially create a new version of that defect. So it doesn't create a new defect, it kind of says, here's your latest status of that same defect. And that has and we can see that in this defect history tab here. So we can see that this defect was originally recorded in July, then August, then November, and then January. But what that gives us the advantage of is within the next iteration of the tool, we actually record work information against it and with the status. So we can say that maybe you planned some work in it when it's first recorded in July, and then when you're told about it again in August, you can see that you've already got that work planned against it. So you don't have to go and sort of look in the lips and work out whether that work's planned. That's all presented to you. And then if that condition was to change, for example, it goes from a pre-alert or alert level to IL level, it will trigger and it will automatically tell you that you've got to review your interventions that you're planned against it, which means that it's helping you to recognize where you might need to make changes to any of that planned work. So I think at 1:15, that's the end of my slot. But that's what I wanted to show, and I'll hand back to Paul.
Cheers, Rob. Thanks for that. Hopefully, that's given everybody a good flavour of what the track geometry and cyclic top elements of the tool do. But there's always the whole thing of don't just take our word for this. And what I'd like to do now is just play a very, very quick video of some of the colleagues that are out on track that are using the tool currently.
My impression of Insight was that it's something that's been needed for a long time now, something that puts together everything that we need in one place, as opposed to going in different directions to get information. It's very good at being able to prioritize what we want to treat first. That is giving us a risk score, giving us a date of exactly when it's likely to become actionable. The push to go green and to come away from using red zone. It's getting access on track is now more important than ever. So I believe using the tool will help everybody, from planners to section managers to people who are in positions like myself.
The Insight tool we've mainly been using for cyclic top, because that's the feature it has that we haven't got anywhere else. So obviously look at the tracers a lot, use LADS and other software like that. But the difference with the Insight tool is it has the cyclic top feature. So we can see like the individual peaks of the cyclic top, which is data we've never had vision before. And we're using that to help sort of prioritize where we're putting OTMs to try and prevent them becoming severe cyclic tops that require speed restrictions. So a couple of examples from the trial we've been doing, and we had one cyclic top site which had a speed on, and the severity was actually due to the number of cycles and not the size of the peaks. So they were quite low dips, but the multiple effect adds up the amplitude. So due to that, it wasn't very easy to see by eye on site, and we tried treating it by stone blower, and it hadn't rectified it, so we'd had to leave the speed on. And we then looked at the Insight tool, and we could see the trigger point further out than what we'd originally identified. And we then treated it again with a stone blower and managed to get the speed off. So that was a useful example.
Within the tool itself, you can see what work's already been previously done there. And obviously, we've been there before and previously treated a site with measure shovel packing or Kango packing, and it's not quite worked. We obviously need this tool highlights to us it's not actually working. Why don't we try a different method? Look at it, may be something to do with the foundation underneath. Do we have to put this in for renewals? That type of side of it. So this tool, the future for this tool, I think, is very, very bright within the maintenance regime. I would encourage people to give it a go because it's a means to work smarter. That's the way Network Rail Vision is, to work smarter going forward. So having this tool and being able to visit a site once instead of visiting it 3 or 4 times to rectify a fault is a huge, huge benefit, not just for Network Rail, but for you as a team as a whole to be able to treat that site and obviously be more productive in going to treat other work that needs to be done.
Please do reach out if you want to be involved in the testing and development of the tool, because at the end of the day, we need to make sure that the program does deliver a tool that is fit for purpose and actually it is suitable to our maintenance team's needs.
So as you can see from that, the tool has been out there now for about a year in a lot of locations. Each region across the country had a trial DU, and that's some of some evidence of the feedback of some of the benefits that the teams are finding with the tool. To move on to the second part of today is around rail management and how we're now going to bring exactly the same functionality we've brought in for the track geometry side of things and cyclic top. We want to bring in for rail management to help rail management engineers. And it's the same principle. We're trying to move back up the P2F curve. Obviously, that time frame of that P2F curve is different for rail management issues. But we want to do exactly the same thing as regards to move maintenance planning earlier in the process. So we're starting to predict a lot longer out. But we're also trying to link the two things together. So have I got a track geometry issue or a drainage issue or something else that's causing me a rail management issue? And what we want to do is consolidate a number of disparate tools that are in the business at the moment, many developed by third parties, And the direction of the business really is that we want to get everything into Insight where possible. So Winsight is the one-stop shop for engineers to do this work and review their information. So things like the rail depth view that we currently have, we will be incorporating into Insight. Looking around, how can we incorporate sideware, gauge face data, RCF data, rail floors, issues with IRJs. So we're working quite closely with one of our other teams, which is all about positioning IRJs. And then also looking about ballast profile through the tool. And again, by managing some of these defects within the tool, we'll be able to decommission other systems and move everything into one place. So rather than an engineer having to have 3 or 4, 5 or 6 screens open to do any sort of reviews or anything, it's one tool, one place to do everything. Again, we're looking to take the data from our measurement trained fleet, so this is a U2U fleet, but also looking at how we can collect manually, get manually collected measurements to supplement those automated measurement fleets. Same principle though, we will look when is a rail depth going to get so severe? Is it growing quickly? Any sort of prediction we can make, and again identifying it and relating it back to track geometry issues. So as we say, the idea is to give an RME greater intelligence in one place than currently they have today. This is an example, and Steve's going to go into the live version of this in a moment. But this is just a few snapshots of some of the slides we will have in the Insight tool eventually. So this is a section of ECM1 on the 1100s. Interestingly, this is another place where we're trying to get UGMS data from the Azuma fleets running up and down this section of track, and we're just about to conclude a piece of R&D work on that with our recommendations to the businesses how we can potentially use that UGMS data going forwards. So we can see here this has been narrowed down to a certain section, 43 miles, 47 miles, so just near Sandy in Bedfordshire. You can see you've got a lot of information about the rail, how much of it within that eighth is of different age ranges of the rail, the rail type, the rail weight, etc., of both left and right rails. What you've then got is the data pushed into the tool from all the various measurement train runs, so we can start to see at any point in the trace what's happening with the data, and we can overlay that data on top of each other to then, through digging down or drilling down further into the data, to start to produce exactly the same charts that Rob showed for the track geometry and cyclic top. We can then do exactly the same degradation charts as we did for the track geometry, and then we can give the engineers again that heads up of the prediction going forwards. The time frame may need to be different for rail management. Obviously things decay potentially more slowly, but not always, and how we can show those predictions going forward, and again measuring the effectiveness of previous interventions. So this has got things in here around field wear and gauge wear. There's other bits in here about curvature, cross level, cant deficiency. So again, we can start to look at how those are degrading over time, and you can isolate these off if you need to. There's then got things like the eddy current data into the tool, and you can see this is a number of runs of data. And again, we will start to highlight. Clearly, we've got issues with data quality and missing data, but hopefully this tool will be able to use historical information to keep those predictions going forward. Even if we get missed runs of data, engineer will still have an idea of the current performance of that section of track until we can either get a recovery run or we can get some manually collected data into the tool to feed into the gaps. So I'm going to hand over to Steve Carpenter now. As I say, he's our senior modelling engineer and who's been doing a lot of the work on the rail management data and visualising that data. So over to you, Steve.
Afternoon, Steve Carpenter. I'm senior modelling engineer. Been working on the development side of the rail management. So I'll run you through an overview of what we've been doing and how it all came together. So, like Paul said already, this is a very long list of data that we've pulled together that we're trying to work out how do we leverage the information we need to go into insights. So this is a POC. So this is not what it's necessarily going to look like when it goes into the final product, but it was allowing us to see all of the data where we were talking with people to see how things are. So like Paul said, top section was about helping understand from the INM system what our rail age was through a particular site, the predominant rail weights and the track category, or sorry, track type through that area. And then, so I filtered this specifically for 103 miles to 106 miles on ECM 1100. The data that you're seeing here is multiple runs that go all the way back to, I believe, 2016. We are now in the process of getting more up-to-date data as the data's been processed through. And the reason we've put that all in is that sometimes when we switch on some of these, you haven't always got a full range of data available to you. So we were having to look at how can we look at these individually and see how they all come together as we were seeing gaps. So we use all of the data when we're looking at this screen. Obviously, we would need to understand how that would work in the final product. So what we've got here is, like Paul referred to, we've got the gauge sideware, which is where we put most of the focus on doing our initial R&D work on working out the P2F curves. Now, what this is showing us is that as we get to this particular point, we were seeing it go above a certain threshold. And then as we go through these thresholds, you get different colors as it goes up, based on some of the information that we'd seen from the business. So we've got all of the other data sets. Now, this is all coming from the KLD laser information that then gets run through into the baseware files. So we're using the Excel baseware files to pull all of this data through. So we've got all of the key elements that we've been asked to bring in here. So just bear in mind where it was between 103 and 104, 103.5 and 104. We had this. As we go down, we can see other elements in that rail that we're also seeing a very strange pattern on some of this as well. So we're trying to look at that and go, how is that affecting all of the rail as we go through that site? So we're seeing a lot of it as we go past the fish plate information. We've got some information about the inclination. We can see something happening in that same area that we would might trigger a defect for you to go and look at and say there's something happening here, and what is that? As Paul said, we've got the curvature, cross level and cant deficiency in here. As he says, I mean, we can switch one to be bigger than the other, so you can just focus on that. This has come from the NMT train and is only for one particular run. We are looking at how we could probably build a curve register from this data. So that's being looked at as part of R&D as well, so that we get a more accurate curve register model put together that comes into here. Once again, if you can see, I mean, it was about that 103 to around 104. We're going through an area there that we've got that, so it could be all related to that and how that's all set up. So one of the other things that we've got, as we said, we pulled through the Eddy current data, and we've been working on as Paul said, there was some gaps in the data, so we've been trying to understand that gap. Is it that there was no recording, or there was a recording and we haven't got the data? How do we align this information? How does that all fit together? The only thing I will say at the moment is that these, for whatever reason, I've not been able to get them to align. These two don't follow what you're seeing at the top in here, but obviously it would follow properly on the final product. We're looking at that. We've then got below all of that, we've got all of the key information that comes from Inham. So what is the rail weight for the left and right rail through that area, and you'll be able to see that we go into it's got the different colors to indicate the different rail weights as we go through that site, and then we can better understand what we're seeing there. We've got the installation date, I believe, for the left and the right rail. Can't remember if it's installation or the rail laid date, rolled, sorry. So we've got this information in here so that we can see, and you can see here that you've got the two rails with two different ages through here. So we can see, oh, is that related? Is there something that we've renewed on the left rail, but we haven't done something on the right rail? And then is that affecting what we're seeing in the other other data from the baseware? Then we go into some of the tonnage, EMGTPA, max axle weight, and the track category, so that we can see what we've run through there. And then the speed, so it's just key data from the Inham file. And then here we've got effectively this gauge we've just brought in from the same train that gave us the gauge data, but the plan will be this will all be brought in from the new aligned data that will be in Insight. So we'll be reusing that leveraged realigned data so that we know exactly what's happening in those sites for gauge and all of the other good stuff that we had in there. And then we've also got our dip information to see if there's anything happening in that data. So some of the key things that we had while we were undertaking this was, from our perspective, when we got the data off of the train, we had we were finding that, and if I just show you this was what our original data from the train was. So we were seeing an odd pattern to say, all of a sudden on one time on the left, or a number of times on the left, we had a whole load of data that didn't look right, and then we also had the similar pattern on the right rail. So what we were able to do was write an algorithm that allowed us to align that data or swap that data. As you can see, with the more up-to-date version of that, we've been able to move based on the algorithms that we've written, which take the curvature model into account and previous runs. We've been able to say all of this data should be on this side. And the reason for doing that is that we've got to go back over a large period of time to be doing our P2F curves. So we need to ensure that our data is on the right side to be able to do that. So we had to build that algorithm. We've indicated it, and I believe they've now made a change on the trains that hopefully will stop that from happening going on in the future. But at least we've got the algorithm to look at that and try and fix that or identify that again in the future. So that this is just to show what the updated and the original look like based on the data going across, to try and work out in a very simple way what the P2F or the trend was for those. We've now also written an algorithm that will be coming into here, or an algorithm that will be coming in here to show us the P2F curve and give us the prediction of when that was going to happen. There is also, and this was when we were looking at the data, and this is the swap data, we were looking at other data sets that allowed us to look at all of the data rather than it in one go, to see if we could see anything in particular that was happening with data sets when we were getting them, to actually look to say, well, is there a pattern? Are we able to see something happening? So we brought these together where you're seeing all of the same data all in one go from all of the runs, with all of the dots for different dates. So you've got the July 2017, we can see 2018, and as we get closer down here, we were trying to understand, are we seeing something happen over time, or were we seeing 2017 and 2019 at the same point to try and help us while we were doing the work? And then we came up with the algorithm that we've built. We were also looking at the eddy current data. So this was trying to work out how we use that eddy current data for both the left and the right rail through that yardage that we had, and identify how many times we've had the account of the number that we were getting back from the system, so that we could see it was a 1 or a 2 or up to a 5. And then we've done that over time, so we can see how that's trended over time. And we did see a number of scenarios that we've had to sort of go back and rethink and speak to a number of key users around the business. What are we seeing? Why are we seeing this? To try and better understand how we can build a P2F curve using this data. So from all of that, we've now been able to build something that will hopefully give us what we want, and will be tied in with, like Paul was saying, tied in with all of the good work that we've already done in Insight, and also look at how we tie all of these together with some of the new functionality that we're bringing in that will allow the decision making required on the rail management side of things. And that's me for all of that. If there's anything else, I'll hand it back over to Paul.
Cheers, Steve. Thank you for that. I'll just share my screen again then for a final time for the last couple of slides. Hopefully that explanation of what we're doing within the tool has given you an appetite, especially if you're within Network Rail, to use the tool once it becomes available to you. I say it's already available to quite a few people, but we'll be getting rolled out fully from April. April and May. If you want to get involved in future development of the tool, we're more than happy to have volunteers to help us build future functionality, to review the functionality we're looking at, to work with us in model offices, mainly because this is not our tool. This is the tool for the engineers to use. This is not another centrally imposed thing that's just going to be thrown at engineers. This is being built for the people who are going to use it, with the people that are going to use it. So I'd like to thank everybody for the time. Has anybody got any questions? I see a few questions going to the chat, which I think I've answered one and other colleagues are answering. Has anybody got anything they want to ask?
Hi, Paul. Yes, thank you very much for the presentation. Yes, please enter your question into the chat, or at least your name, then I can call you to ask the question. Andy, do you want to come in?
Oh yeah, it's Andy Franklin. Yeah, so a couple of questions that I've already asked. So I mean, I really like the system. I really like the graphics now. As an engineer, I like a good graph, and I don't like Excel spreadsheets, so it's really nice to see that. And I think you've already answered this in the question, but there's a couple of things. First of all, are we going to put track diagrams in it so you can actually see alignment with track diagrams and other features? And is it also possible to compare, say, the up and the down main to see if you've got effectors affecting both lines at the same place?
Yeah, so one feature we didn't show you on the when Rob was doing his demonstration is when Rob was looking at, I think he was looking at the 1100s at 57 miles on DCL. There's two things that could have been done at that point in the track. Firstly, you can just by swapping the charts and going into the filters, we could have looked at gauge, dip, top, twist, alignment at that location, and then we could have just swapped quickly to the 2100s, and it would have done exactly the same, and we could have gone through the same exercise. We were a little bit restricted on time, otherwise we would have gone into that. But that functionality is there, certainly, Andy. You've also then got the functionality that if you're looking at a cyclic top location, you can quickly go and say, well, show me the obvious triggers for a cyclic, which is probably going to be a dip. Are there any dips in that location? And you can do exactly the same in the tool there. So you can start to do that analysis of quickly looking through all your parameters, and if you've got a cyclic, potentially looking for that dip. And as I think Rob's answered and I've had, yeah, the plan is to get a schematic in there, and we've got a wireframe. We're trying to sort of use something that looks very similar to the LAD type schematic, but with a lot more enhancements to it.
Okay, that's excellent. Thank you. So I've got another question, if you want.
Go on.
Right.
Yeah,
the thing that makes me nervous about this is long-term support for this project assured?
Yes. So at the moment we have funding to develop quite a lot of the features we want to do to really get the tool embedded in the business. We will operate the tool and manage the tool through the rest of CP6. We're still looking for more funding opportunities to develop future functionality, because every day somebody asks for something from new or some enhancement, or we actually see something as we build the tool going, oh right, if only it didn't that. So we are looking for new funding opportunities to build even more into the tool. Coming already funded is things like intervention decision support, being able to do track quality reviews and trace reviews through the tool. So instead of annotating pieces of paper that you have to do now, you'll be able to do that within the tool. That's all sort of assured to be built within the tool. And then the current plan is that this will become a business as usual tool as of the end of CP6, and therefore will continue to be developed into CP7, either by our team or being developed by Root Services.
Thanks very much. Excellent.
So the long-term vision of Gareth Evans, especially as professional head of track, is that Insight is his go-to tool for all his engineers to work with. So with that level of support, you can see that from the business side of it, they want this tool to be a success.
Good. Thank you.
Okay, thank you. Darren, there's a question on the chat about designer having access internally and externally.
So at the moment, external access is not available because it's only available to network within Network Rail. But you can with the Network Rail, if you've got a Network Rail login, you can access the tool as long as your account is set up. If anybody wants an account set up within Network Rail, I can do that. Just drop me a note. The contact details are on this slide presentation at the end, and we can set you up. Unfortunately, at the moment, we cannot grant access to outside of Network Rail.
Probably worth mentioning as well, Paul, that we're always looking for more use cases around where the tool could be applied to other scenarios that would obviously bring benefit to the business.
Yeah, so one of the things we've looked at is as part of the Transpan and Upgrade team, they want to use the tool to monitor their existing infrastructure as they build new infrastructure. So where they're moving from 2 roads to 4 roads, they want to make sure that nothing they're doing is impacting on the current infrastructure. And then going forwards, they will use the tool because UGMS will be fitted to the service trains running on Transpan and Route, and they'll be using the tool even more to monitor their infrastructure. So again, that's another a good business case. We can also use the tool if we can to monitor as things are installed to make sure that instead of having to go out and send people out to do surveys, we can understand the infrastructure that's being built.
Okay, thank you. I've got a question, Paul, is thinking of my own role really as a assurance and risk engineer in the Western region. What I would be interested in is to understand from I guess, a section, a DU, a route, or a region perspective, what are the key data in terms of fault prediction, correction, to see how we are improving overall at all the different levels. So is there something built into the system to be able to produce reports, for example, on a periodic basis, to tell us how we're improving or not?
Yeah, so the improvement, there is an improvement within the tool, or a process within the tool which we call backcasting. And what we do is we look over the historical performance of the tool and predictions and interventions, and we're constantly monitoring that to see whether through any changes we made to the algorithms or any way that the tool processes the information, whether that score is improving. So as I said, we have an accuracy level. Last time we did backcasting was around 72% on prediction time frame for coming up with the right time that was going to pass the threshold. We've improved various functionality within that, and then before we go live with the tool in May, we'll be running that exercise again. It's quite prevalent on your route because we get asked a lot of this by Mr. Pearson and Mr. Bartlett, who are constantly pushing us to look at how can we improve that score. Regarding locational accuracy, we use a thing ironically called the Pearson correlation coefficient, not invented by the man himself, but by somebody else. And what we do is we measure the accuracy of our locational alignment. The target score is 1, being perfectly aligned, and currently we are running at a score of greater than 0.98. So we know that we are very well aligned, so that we know that within sort of a yard or so we are looking exactly the same point in the track every time. There is a point of diminishing returns as you try and improve that. You're spending a lot of money to make very, very small incremental improvements. If we're down to sort of a yard of plus or minus, then that is a lot more accurately than we can send people on the track using, say, the Where Am I app that they have on their phones, which has something like a +1 - 3 meter tolerance. So yeah, and what we should be seeing through measurement is, we should be seeing a reduction in the number of service affecting failures. Is a good matrix that we're not getting that, or the number of repeat failures is going down as a result of using the tool, or we're making better utilization of our possession opportunities. So if we do get possession, I've knocked off 5, 6, 7 defects out of the tool in this one instead of just going to treat 1.
We're also we're working on or scoping out the requirements at the moment for the track quality part of the tool. So we will be bringing in, obviously, track quality is a standard deviation over 8s, but also within that, those widgets I demonstrated on the front page would have PTG and GTG, and which can be set at your section level, your maintenance engineer level, DU or route, and then you can use that to identify what the PTG, GTG is now, but what also predicted would be over the next time period to be confirmed. But then from that, you can then go and find all of those 8s which are degrading and are going to impact on your PTG, GTG scores. So yeah, we're starting to do some predictions on overall track quality, PTG and GTG scores.
Okay, thank you very much. I think there were a few conversations actually in the chat, so I'll let people catch up with that. But I cannot see any more questions. Okay, so what I propose then is that we draw this section to a close. I'm going to echo what Andy is actually already put in the chat. It's a very interesting presentation. it's great to see, this it will be developed and having the testimony from the people, who actually been in the front line and explaining what the benefits they get from it. I think that I found it very interesting because that's what the tool is built for. And I noticed there were, people from the region, frontline people, TMEs, attending this presentation. So I'm hoping that they got a lot from it, and they are engaged or will be engaging with the system and the team in the near future. So
yeah, I mean, as I say, my contact details are on the end of the presentation, Gilles. So when you share it, if anybody wants to get in touch about Insight, either to get access or more detail, or want us to do a local demonstration or a longer demonstration of the actual functionality of the tool for their particular DU or section, more than happy to do so.
Brilliant. Thank you very much for the offer, Paul. So on behalf of everybody on the call, I'd like to thank you, Paul, Steve, Rowan, Martin for answering the question live in the chat as well, and all the other people within your team, for coming and do this presentation today. So thank you very much.
Thank you all.